you hear me?
Yep.
Okay. Does that still look okay?
The video's playing right now, Craig.
Okay.
Good afternoon. I'd like to welcome everyone here to the Environmental Tracks last session of the afternoon, which is the updated KYTC noise analysis and abatement policy. I'm Mike McGregor from Bacon Farmer Workman Engineering and Testing, and I want to thank you for joining. As we get started, I would like to introduce the presenters for this session, which are Michael Leathers and Craig Craig. Again, this is the updated KYTC noise analysis and abatement policy. And with that, I'll hand it off to you fellas.
Okay. Thank you, Mike. I'm Craig J. Craig. I'm with the Transportation Cabinet, Department of Environmental Analysis. I've been doing the noise portion of that for about a year now, and enjoying it so far. And with that, we'll go ahead and go over the 2020 update to the noise policy. And like I said, this is the updated KYTC noise analysis and abatement policy. Welcome to the 2020 Partnering Conference. Okay, relevant guidance to the policy. These are all taken from previous policies. It's just a brief timeline here of what we've been working with up to this point. July 13th, 2010, FHWA published a final rule updating for 23 CFR 772, procedures for abatement of highway traffic noise and construction noise. In July of 2011, KYTC updates their noise policy, which supersedes the old 2000 policy. And July 1st, 2015, we updated to the 2015 policy. Yeah, I'll just be going over some of the major changes to that policy, which you can find all these in the new 2020 policy, and we also published a list of changes for the 2020 policy. This is all can all be found on our website through the KYTC homepage. Okay, we just generally updated the formatting. General formatting, added references to KYTC and FHWA policies and guidance documents. Definitions, added receivers and sound attenuation to the definition list. Screening tool, this is a new type of methodology which Michael will be going over a little bit later. And there is a discussion in that, and a copy of the tool can be found in Appendix B of the noise policy. Study area. Policy maintains a 500-foot edge, 500 feet from the edge of pavement. If we do experience impacts at the 500-foot mark, we'll expand that on out to 800 feet. This also includes the equivalent residence calculations. Activity category A, just added some additional details. Okay, changes in the policy continued. Receptors, additional guidance and clarity for modeled receptors. This includes multifamily dwellings, analysis of multifamily dwellings with multiple floors. Grouping, a single receptor can be used to represent a small group of receptors now. However, if the group is impacted, individual receptors will be modeled individually for the abatement analysis. Noise level measurements. We added some additional requirements. Most of the reports I've read, you guys are already doing this, but it's now a requirement. Microphone height 5 feet above ground surface. Measurement time has been increased to 15 minutes. And worst hour, added clarification for the LOS and special situations. Acoustic feasibility. Also adds clarity to what is considered an isolated receptor, or if the feasibility meets the 3 benefited receptors rule. Acoustic feasibility continued. Radius of 115 feet encircling the impacted receptors used to determine if the receptor is considered isolated. There's always seem to be a lot of questions on what is considered an isolated receiver or a group, so that we can get the CBR benefit, but we want to make that a little more defined. And 2 additional impacted receptors must be present within the 115-foot radius in order to meet the 3 impacted receptor criterion. Cost reasonableness provides guidance on dealing with adjacent barriers and group receptors. Policy no longer allows benefited receptors to be grouped and the cost of abatement to be averaged. The policy does, however, allow for barriers to be grouped when adjacent to one another. Barrier grouping can be applied when barriers are adjacent to one another and provided benefits to more than one area of group receptors. And when we say adjacent barriers, that means barriers that are in line with each other, not next to each other. Okay, continuing with the 2020 policy, cost reasonableness continued. Other considerations, the updated policy removes the barrier adjustment calculation for benefited receptors for the NAC, and the difference between the predicted and no build noise condition exceeds 10 decibels. So based on this, we'll no longer need an analysis for a no build alternative. documentation and reporting, feasible and reasonable barrier walls. Additional information is required for proposed barrier walls, such as location, length, description, table including wall segments, bottom and top elevations with coordinates. Once again, most reports I've read already included all that, but it's now a requirement. And noise impact screening tool. Policy outlines projects cleared using the screening tool. Okay, updated cost effectiveness criteria. Cost of barrier wall. We ended up analyzing 3 different barriers over the past 3 years, and through that we came to the conclusion don't need any change in the $30 assumed cost, and the $30 per square foot is maintained in the 2020 noise policy. Cost per benefit or receptor still at $35,000. Probably look at this again in 5 years when we update the policy again in 2025. Screening tool noise for noise analysis. Biggest reason we did this is on the slide here. Historic data shows that low volume rural roadways seldom reach NAC levels. Often when these types of projects do create impacts, the receptors are isolated and barrier mitigation is not feasible. And the purpose of this tool is to remove costs and time from projects. Okay, real briefly, screening tool development timeline. June of last year, KYTC had initial discussions with FHWA on limiting TNM-based noise impact analysis, and they requested we go ahead and proceed with doing that. So same month we had discussion with H&B and talked about our goals and requested they kind of research what other state DOTs were doing, limit the number of TNM-based noise analyses. August 2019, met again with H&B, and wanted to discuss Oregon's approach. They were kind of on the forefront of developing a method that does not include a full-blown TNM analysis. And H&B gave us a concept of ideas that we thought were good ideas, so we asked them to go ahead and continue with that. January 2020, FHWA requested that KYTC update their noise policy, and we decided then that we would go ahead and include the screening tool with that update, along with the updated barrier costs. So, goals of the screening tool are to develop a tool allowing for project screening of low-level projects, to eliminate full highway traffic noise impact analysis, and to account for project impacts, both at the same time. Provide a basis of analysis of potential alternative impacts due to highway noise to satisfy NEPA and 23 CFR 772. And also develop some standard template language for use in the NEPA documents when the screening tool is utilized. Implement the screening tool into the guidance for KYTC DEA and FHWA to use during project scoping meetings. Okay, and with that concludes my portion of the presentation. I'm going to turn it over to Mr. Leathers here, who will give you in-depth look at the screening tool and the development of it. Thank you very much.
All right, thanks, Craig. Let me make sure that I get this screen right. Okay. So like Craig said, they contacted us, wanted us to try to come up with some ideas to screen projects. They didn't want to have to do a full-blown analysis. for every type 1 project like they're doing now. And so our first discussions were based around 23 CFR 772.9, which calls that you have to use FHWA's traffic noise model software or another model determined by FHWA to be consistent with the methodology of that program. So that's the way we were framing our discussions, and any thought process, any ideas we had were modeled around that. So the first thing, like always, the first thing you do is just kind of look to see if someone else has already done it. You Google it, you look elsewhere. So we downloaded the noise guidance policies for all the other states. We looked at FHWA's guidance documents, and we found that there were 2 states that were doing a screening process of the projects, Oregon and Idaho. And Oregon had the one that was the most similar to ours. They had a straight line model that used T&M to screen projects, just like what we're talking about, to try to find which ones are unlikely to experience noise impacts. And so that was along the lines of what we wanted. Idaho had another one. Theirs was a little bit different than what we were going for. But the one thing with Oregon's is that it's still required a separate T&M model for each project. And that was a little bit counterintuitive to what our ultimate goal was to try to come up with something that eliminate that need altogether for a project-specific T&M run. That way, the ECs and the districts who maybe don't know how to use the T&M software could use this screening tool. So we used that. We figured we were kind of on our own coming up with this idea. So we did a little bit of brainstorming and came up with a couple ideas. And what we came up with is a 2-step process to determine the level of analysis required. First step would use the project-specific data, the speed, DHV, the truck percentage, to predict the noise level for the receptors that are nearest to the proposed roadway. And the results from that step would determine if the project would reach NAC levels. The second step is using, if you had impacts in the first step, if that's project-specific data shows that you can reach NAC levels, well, then we're going to take a look and see whether there's other impacted receptors near it. KYTC's feasibility criteria requires there to be 3. Well, requires there to be benefit for 3 impacted receptors, and the benefit was a noise reduction of 5 decibels. So, we were trying to figure out what's that distance to where the minimal distance to where you could reach that. You could get 3 receptors benefited and still have a wall that's feasible, that meets the cost criteria. So that was the 2 methodologies we came up with. We're going to go through each one of them here. I'll try to give a little bit of a background on the calculations and how we came up with it. Like I mentioned a second ago, there is some project data that is required to run this. Just 3 things, really. You have to have your design speed, 30, somewhere 35, 45, 50, whatever it is. You have to know your design year traffic volumes. DHV is obviously the preferred traffic volume count. That's what T&M uses. But we have built in a conversion calculation to where if all you have is the ADT, the average daily traffic, the screening tool will convert that to the DHV. So either one of those methods will work. And then, of course, the percent trucks. That's another traffic volume data that you have to run this. And then project mapping. You have to know the edge of pavement. You have to have your alignment. The way T&M works is it measures the distance from your receptors to the edge of the proposed pavement. So you have to have some mapping for that. And also to do the evaluation, of course, just to determine that distance to see if you have 3 impacted receptors within the distance. So that's all that's required to run this tool. But I will note there at the bottom, it says that the tool shall be utilized for each individual segment. So if you have a rural and urban section where your design speed changes, each one of those segments need to be analyzed separately. Same thing with volumes or percent trucks. Anytime you have that, you need to look at it individually. So step one, like I said, it's predicting the noise value. Like we mentioned earlier, it all has to be based around T&M. So what we did was develop a straight line roadway in T&M and put receptors at grade, so it can be used on any project. There's no change in elevation. We have receptors spaced out at various intervals from 30 feet to 500 feet off the edge of the pavement. And then once we had that, we established a noise baseline. So we did separate runs for 25 mile per hour speed up to 50 and 50 and 5 mile per hour increments. And we did this noise baseline for one vehicle, one car, and one heavy truck. And that establishes your kind of like your baseline speed or your baseline noise level, excuse me. This was our table. You see the one on the left is for automobiles. It may be kind of hard to tell, but along the x-axis is your design speeds. Going up and down and is your distance from the edge of pavement. So we have from 30 feet to 500 feet. You'll notice if you can see the numbers, we go from 30 to 200 at every 10-foot intervals. And then from 200 on to 500, it's every 50 feet. And the reason why we did that is because the graph for the distance and how the distance impacts the noise level, it's a nonlinear graph, but the most of the change is in the 0 to 200 feet. So once you get to that, it's a pretty linear equation. So we were able to add a little bit more distance there. So once we had that baseline, we have the noise level for one vehicle, one heavy truck. We then use the project specific data, which is the distance, to interpolate what is the noise level for one automobile and one heavy truck for that at that receptor. What's the noise level at that one receptor? So going back to the tables, there's a bilinear interpolation there where it takes the design speed and the distance and comes up with that value. Then after that, you use the project specific volumes and it adjusts for that volume. So the equation there, I'm not going to go through it. But that's what the calculation in the background is doing. It's that equation comes out of T&M's guidance documents on FHWA's website. So it takes that one vehicle speed and just interpolates and adjusts the speed. And then once you have those, that second equation there combines the noise levels for your for your vehicles and for your heavy trucks. That's the equation. It's not a linear equation, so it's a logarithmic. That gives you your noise level. So once you have your predicted noise level, the screening tool will flag anything that's 65 decibels or greater. Receptors there, most of your residences have a 66 is what we consider in Kentucky as an impact. That's approaching the NAC, which is 67. So anything that exceeds or approaches is considered an impact. So in Kentucky, we consider anything that's 66 decibels an impact. But for this screening tool, to provide a little bit of a margin error that we have found, within the calculations and the way that's interpolating for the distance to the receptors, we are using 65. So anything that's at 65 decibels or greater will be flagged. That's the end of step one. So then we go to step two. Like I mentioned earlier, this is only required if step one identifies impacted receptors. So what it does is it takes into consideration KYT's feasibility criteria that requires a minimum of 5 decibel noise reduction for a minimum of 3 impacted receptors. So what this will determine is if impacted receptors are isolated or if a noise barrier is feasible or has the potential to be feasible. You'd have to do the analysis, of course, to make that determination, but this just tells you if it's even possible. So again, it has to be based around T&M. That's what we follow throughout this whole process. Again, we did a straight line road in T&M with at-grade receivers. This time, the receivers were all placed in line 50 feet from the edge of the pavement and at 20-foot increments. And then what we did is we put in a speed and a traffic volume and adjusted it accordingly until we got those noise receivers to reach a 67 dBA, which is the NAC criteria. Once we did that, we put a barrier wall in. So we put in a 5-foot or 12-foot tall barrier wall, 5 feet from the edge of pavement, parallel to the roadway. It's 290 foot long. You may ask, why 295 feet? Well, what that is that's the longest wall possible at 12 feet tall that could benefit 3 receptors and still meet the $35,000 cost effectiveness criteria. So anything greater than that, if you divide it by 3, it's going to be over 35,000. Wouldn't meet that cost effectiveness and wouldn't be considered reasonable. So that's how we came up with the 290 feet. So again, once we had that 290 foot wall in there, we ran the barrier analysis, and we looked at the results, and we found which of those receptors that were spaced 20 feet apart, where the noise reduction with the barrier wall fell below 5 decibels. Once we found those, we moved them in. We'd move them in 5 feet. We'd run the model again and see if that barrier got to 5 decibels of noise reduction. If it didn't, we moved it in a couple more feet. We kept doing that until we found where it equaled 5.0 decibel noise reduction. When we did that, those outside receivers were around 230 feet apart. I think there was actually like 226, so we rounded it up. So we figured that 230 feet is the maximal, or is the distance to where you can still have a wall and meet the feasibility criteria. The result is, so you have to have at least 300 impact. Once you identify an impacted receptor, you have to have at least 2 more within a 115-foot radius of it to satisfy the feasibility criteria. So locations where this occurs are considered a cluster capable of meeting KYTC feasibility. And where this doesn't occur, they are isolated. Therefore, you can consider them, there's no wall that would be feasible. You don't need to do a barrier analysis in that situation. That goes back to the policy. We incorporated that, the work we did around this wall to incorporated that also in the policy. So even if you do a full barrier analysis, you can look at it for this 115-foot radius and throw out a barrier analysis if it's not within that distance. All right, next we'll do a walkthrough. That's kind of all the math behind it, the calculations. So let me pull up the Excel spreadsheet. And I realized earlier that the screen on the this website is a little bit small, so I've tried to make this as big as possible so that you all can read the text. I sure hope you can. If not, just let me know. Maybe I can go over it later some other way on Teams or something. But the walkthrough I'm going to do is this 2+1 project that we, H&B, did a noise study for in Marion County. We've done a couple of these. It's for the Heartland Parkway. They're doing a series of 2+1. It's where they have 2 12-foot lanes with 10-foot shoulders. They're converting it over to 2 like 11-foot lanes with the middle turn. Well, 2 travel through lanes in each direction, and then the third lane changes in which direction it goes into. So it's a newer type of roadway improvement. Try to add some capacity without impacting a lot of right-of-way, without making, you can use your existing pavement to do this widening. So it's something they're doing several places along the Heartland Parkway, which is meant to connect the BG to the Cumberland Parkway. And so we did a noise study for this in 2018 on Kentucky 55 in Marion County. I travel this frequently because it's here in my hometown, but just to go through the screening process and show what it could have done instead of full analysis. So on this project, we had a design speed of 55 mile an hour and a DHV 1029. I don't need to type in the ADT since I had the DHV. So we only have to input the value for one of these 2 cells. Percent trucks on that project was 5%. And that's it. So you can see here that I guess I skipped over step 1. That was just determine the number of road segments. It's kind of what I mentioned earlier. Anytime your traffic changes, you need to kind of identify that and run this for each one. And then on step 2 is when you input those roadway characteristics. So I've input mine for this project. There was only one type of traffic volume, only one truck percentage. So I only have one segment on this project. I've input that in. Second, the next step, insert the distance from the proposed edge of pavement to the nearest receptors. All right, so I'm going to go over to Google Earth. This is the project that I have here. This is the 2+1 project. It's right along the Washington County line going into Lebanon. And so we evaluated this. We went out, we measured the distance to the houses. And the closest one was 77 feet. So going back here, I'll put in 77 feet. Hit enter. And you can see that this noise level automatically shows up 68.4. It highlights it red. That is considered noise impact. The next closest house on that project was at 90 feet. It too was over the 65 decibels, so it's flagged as an impact. The next one that I had was 120 feet. It's less than 65, just barely, but it is less, so it's green. It's not considered one. We had one at 137 and another receptor at 152. So at this point, I would evaluate step one. Step one shows we do have impacts on the project. Since we have impacts on the project, I'll have to scroll down to step two, which is going to look for the barrier feasibility screening. Because we don't have 3 impacted receptors, I could already tell you that we're not going to have 3 impacted receptors together. But just for the exercise sake, we can go over here on my Google Earth. I have a little points for all of the receptors on the project. And these two here are the impacted receptors that were at 77 feet and 90 feet from the edge of pavement. So obviously I can measure the distance. You know, I can measure this from here, see that there's one within 115 feet. If there was another one, you know, you just do an evaluation. You can use Google Earth, you can use the plan sheets, whatever you have available for the project, you can do. Take the measurement. So obviously the answer to step two, which asks if there are also 2 or more impacted receptors within 115 feet, would be no. When I did that, that highlighted green, and hopefully you saw that this column down here got filled in. This is our conclusion statement. This conclusion here says that the screening level analysis was performed on the proposed build alternatives and showed that while there is the potential for noise level impacts to nearby receptors, there are not at least 2 other impacted receptors near that receptors. So as a result, noise abatement measures would not satisfy KYTC's feasibility requirement, and therefore no structural noise barrier will be incorporated into the project for the abatement of noise impacts at these isolated receptors. This gives the user, whether it's the EC or whoever's doing the NEPA document, can double click on this, copy this, fill it into their CE form, and be done with the noise analysis. The only other thing that would be required would be to include a copy of this screening tool as an appendix. And as it says up here in step 2, if you have impacted receptors, but they were not, did not meet the step 2, we also ask that you include a copy of your plan sheet, of your Google Earth, a screenshot, something, just for your own backup, just for the proof of what, you know, the study that we did. So that's the first walkthrough. I'll go up here and show that. So say we had another impacted receptor at 95 feet, and it too was impacted. So now we have 3. Let's assume all 3 of them are near each other. We change this. I'll scroll down so you can see the conclusion statement. If I change that to yes, it's going to change that to red. And down below, it's going to tell you that a full traffic noise analysis is required because this screening shows the project has potential for noise impacts and that a barrier can benefit 3 or more receptors. So again, this is all automated for you once you input the results. If I change this back to no, the only other option, I guess, is if getting screened out through step 1. I believe if I change this to 45, let's see, 35. So just to get us the results that we're looking for here, I changed the design speed to 35, and it made all of these where they weren't impacts. So I can go down here and see that I have my final conclusion statement option that says the screen level analysis was performed and that there are no potential for noise level impacts to nearby receptors. So that's kind of the walkthrough. Again, you can do this walkthrough. The plan, the expectation is this is done, or at least considered during the scoping phase early on. Transportation cabinet. So here's the do's and don'ts for how you can apply this. This should be used by KYTC only, not used by the consultants. Like I was just saying, that this is meant for during the early scoping phase. You can evaluate, run your projects through here, see if even the screening tool is an option. If it is and it's showing that no impacts, someone within KYTC can do that and be done. You don't have to get a consultant. Unfortunately for us, this is one project we're working ourselves out of work, but that's just kind of a requirement we felt was necessary for it. Another kind of restriction is that the design speeds need to be between 25 and 55 mile an hour. Anything bigger than that, so you're typically talking interstates or those type of projects, and this tool really doesn't need to be used for that. You really kind of need to focus, do the full analysis when you get to that level of a project. Also, projects on new alignment, you do not use this tool. You don't have the proper noise readings necessary for this tool for projects on new alignment. So we can't do it for that. You can use this project when you have category B and C receptors. Those are the ones that have the NAC that's at 66. So you can use it for that and undeveloped lands. You cannot, on the other side, use it for projects with category A receptors. That would require coordination with Craig and those at KYTC and potentially with FHWA. Finally, like I mentioned, you need to include this as a printout of the tool as an appendix in your NEPA document. If you have receptors that are potentially impacted, but they're isolated, it's like I mentioned, it's good to have a map of those areas and also include that. Then, of course, you couldn't come up with something like this without coordination through all FHWA. So as Craig mentioned, we met with FHWA, the Kentucky office, and just kind of showed them a proof of concept. That was early March of this year. They were on board with it. They supported the idea. They thought everything looked good. So we went back and really refined all the 2 steps that we have here and came up with the screening tool, came up with that Excel sheet, and we provided that to FHWA headquarters in Washington. And they took it and they provided it to the VOPI Center, which, just to be honest, hadn't heard of the VOPI Center before all this, but they're the ones who came up with T&M. They're the nuts and bolts behind all of that. So they really understand how it works, the nonlinear relationship between the speed and the pavement and how all those interact within the T&M model. So that was a great resource for our team, for them to look at this. And they looked at it, provided some comments back to us. And after they provided comments and we had a chance to review them, we had another meeting. This time was with FHWA Kentucky, FHWA's headquarters in Washington, and a couple folks with the VOPI Center. So we were able to walk through their comments. They gave us a couple great suggestions that really tied down our margin of error with the straight line model and the interpolations that we were doing. So we went back, we made the revisions that they recommended and resubmitted the screening tool shortly after that meeting. And they took another look at it, and they both signed off on the screening tool about the end of May, which is great timing for us. It gave us enough time to incorporate it into the updated noise policy, which of course we had to submit there in June so that we could get all the signatures and approval for it to be implemented at the beginning of July. So in summary, we have that updated noise policy like Craig talked about. It went into effect July 1st. A lot of it is pretty similar to what we had before. There's a few changes in there, like the taking out the no build analysis, a couple other things, but really try to refine that. There wasn't any change to the cost effectiveness criteria. We did that evaluation, found that we were still under that $30 per square foot, so there was no change there. And then the big change here, and especially for those in the cabinet, the ECs and the project managers at DEA, is the traffic noise screening tool. It's going to provide a basis of analysis of alternatives for noise impacts. It's going to allow them to screen projects without requiring project-specific T&M runs. It will eliminate some highway traffic noise impacts. That's the goal. As Craig mentioned in the comments, I see that it should save them quite a bit of money over time every year, and that money can be used elsewhere, whether it's a safety project or stream restoration, or that any savings, especially in this time, that we can provide the cabinet is a big deal. So this will provide significant cost savings, and it will also save some time. I feel like a couple of those 2+1s we have where the project was getting close to letting, and the KYTC folks, it was just a CE1 or 2. They were trying to get their NEPA document done, and were like, hey, we need this is a type 1 project because we're adding capacity, so we need a noise study. And they had to go and get us and try to put us, we had a tight timeline on those, try to get them turned around in time. So having something like this will be a big time savings as well. So really, that's all we have. A little bit early today, but I think at the end of the day, everybody may be glad to get off 10 minutes early. So we have plenty of time for questions if anybody has any. Let's see. Donna asked, Donna Harden, District 5, asked if there's something that this is something Craig will run, or do the ECs in the district need to learn how to use the tool? Craig, and correct me if I'm wrong, but I think both of you all plan on using it, right?
Yeah, I mean, it'll likely be mostly utilized by myself. If they want to learn how to use it as well as a backup or whatever, that'd be fine.
Yeah, Donna, and I think we have a kind of a how-to write-up document that we have put together for it. So you can probably get that from Craig or Tim Foreman. Craig and Tim were heavily involved in this throughout the whole process, and we worked closely with them. So they have a lot of knowledge about how this whole tool got put together, and should be able to help out at all. And plus, we can always help walk you through it again if you need. David, yeah, that sounds good, Donna. David asked, there was some mention of using at scoping, and how will the tool be used for scoping reconstruction projects where the alignment is not known that early? It's a good question, David. I think maybe at scoping is just trying to identify whether this is even a potential to use this tool. Obviously that will change as alignments get developed, but I think that's the point where KYTC can make the decision whether noise needs to be, well, I guess you could add noise in later. You're right. There is some kind of timeline impacts there, but I think Craig and some of the folks will have a good idea, especially after we get using the tool, when it would apply and when it wouldn't. If you look at a project maybe in Eastern Kentucky and it's a bridge replacement or a small project, just where it's maybe moving a little bit closer to receptors, you could evaluate aerials and see whether there are receptors that are spaced apart. I don't know. It's something we're probably gonna have to work through between Craig and Tim and the consultants, kind of figure out the proper time to implement this. Is there any other questions? End of the day, everybody wants to get off a couple minutes early. Tim, there will be, okay. Tim said there will be a memo going out soon with some guidance. And he mentioned coming after PL&G typically. So And
Yeah.
yeah,
That would be a KYTC memo. Went out to the EPMs and DECs.
yeah. And Craig mentioned there at the end, I do want to give a lot of credit to Mitch Green at our office and Mark Davila. They did a lot of the T&M and a lot of the brainstorming on this. So all I did was try to put the screening tool and pretty it up a little bit, but they're the brains behind the whole thing. All right, I guess that's it.
Thanks a lot for joining us.
Have a great weekend.